Welcome from Teacher Richard. During this presentation, we are going to explore the Pythagorean theorem. Now, the Pythagorean theorem works with right triangles only. So we have to have that 90-degree corner down in that area in a right triangle. What we have here is a ABC triangle, and I've listed the values over here. So I'm going to call this a 3, 4, 5 triangle. And I'm calling it that because the linear units of this side A are 3 units, the linear value of side B is 4 units, and the linear value of the hypotenuse side C is 5 units. Now, the Pythagorean theorem tells us that if I take this hypotenuse, which is always the longest leg, and I square the linear units, in this case I have 5, if I square them, I have 25 squared units, as shown on this graphic area here. There are 25 squared units. The Pythagorean theorem tells us that this value of 25 squared units is identically equal to the squared sum of the squared units of this side A and this side B. So A squared over here, 3 squared is 9, 4 squared is 16. So we have 9 squared units here, 16 squared units here. The sum of those two values added together, 9 plus 16, equals 25. So we have the 25 squared units over here, and that is exactly equal to the sum of the squared units of the other two sides of the triangle. So after we have, if this was an unknown value, and we had gone through the math and squared 3 to get 9, and we squared 4 to get 16, 16 plus 9 is 25. We take that 25 value, which is a squared unit value, we square root it to go from an expanded value down to a contracted value or a linear value, and we end up with 5. This always works on a right triangle. So the Pythagorean formula over here tells us that the value of c squared is equal to the a squared plus b squared. So these two legs squared are always equal to this one leg squared, the hypotenuse squared. Now we can cut through the math a little bit and go down to this set of formulas down here, which states that the linear value of c is equal to the square root of the other two legs squared and added together. So you add a squared plus b squared and then square root that value, and that'll give you the linear value of c. If we had an unknown value for leg A or side A, the solution for that unknown side A would be the square root of c squared minus b squared. So we would take and square the hypotenuse value and then subtract the squared value of b, then square root that answer, and that would give us the linear value of a. And then, very similar down here, if we had an unknown value for leg B, we know the answer is 4 units. If we had an unknown value for leg B and we wanted to solve for that, the answer is the square root of c squared minus a squared. So we would square c, come up with an expanded value of units, subtract the expanded value of these units down here, So these expanded units minus these expanded units equal these expanded units, and then you square root those expanded units to get the linear value, which in this case will be 4. Now we'll go to the next page, and I've worked this out in steps so you can see how this works with the calculator. We have the exact identical triangle in 3 different places here that we had in the previous page. It's the 3, 4, 5 triangle. We just have to imagine that we don't know a value as we progress through this. So in this case here, I'm imagining that I don't know the value of C. So the formula from the previous page tells me that the linear value of C is equal to the square root of a squared plus b squared. Then we substitute our actual linear values, and C is equal to the square root of 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. So C currently is equal to the square root of 25. When we do that square rooting operation, we end up with C equals 5. And here are the calculator strokes. For my calculator, the Texas Instruments 30XA scientific calculator. And these numbers here that you see in the parentheses are going to be what you're going to see in the display of that calculator when you hit the button to the left. So 3, which is leg A, squared, that's in the display, so 3 squared is 9, plus 4 squared, that's in the display, equals, we got 25 in the display, we hit the square root button, and we end up with 5. So I can demonstrate that over here on this calculator. I can put in a 3 squared plus 4 squared. You notice I have that 16 in the display here on this calculator because I just hit the squared button for 4. Now I'm going to hit the equals, and I have 25 in my display. Now I just hit the square root button, and I'll end up with the linear units for this hypotenuse. And this is the square root button right here. And there's our answer, 5. Now let's move over to this triangle here, and we're going to imagine that this is an unknown value. We actually know the answer is 3, but we're going to imagine that we don't know that yet. So the solution is A, linear A, is equal to the square root of C squared minus B squared. And it's equal to the square root of 5 squared minus 4 squared. And A is equal to the square root of 25 minus 16. A is equal to the square root of 9. And 9 square rooted is 3. And here's your calculator strokes right here. Here's your hypotenuse is 5, so, or C. So 5 squared minus 4 squared equals square root. And it's very similar over here, except it's a different unknown value. In this case, we're imagining that we don't know the value for B. We know the answer is 4, which it shows us down here. But if we walk through the formula, B equals the square root of C squared minus A squared. b is equal to the square root of 5 squared minus 3 squared. b is equal to the square root of 25 minus 9. b is equal to the square root of 16. When we square root 16, b is equal to 4. And here's your keystrokes over here. Now, that is about it. In the next video that I'm going to put together, I will be not using a known a triangle with known values. I will be putting in values that we don't know the answers, and we will go through the keystrokes to solve for the unknown values. I should point out here that one concept that you should burn into your head is the fact that there's only two possibilities here when you're doing the Pythagorean theorem. You're either solving for the hypotenuse, the longest leg, or you're solving for one of the other two shorter legs. So if you're solving for the hypotenuse, you're always going to be squaring and adding values together. So it's a addition problem, which you see down here, addition, the plus sign. The other two possibilities, you're solving for one of the other legs, not the hypotenuse, but one of the other legs on both of these situations. In that case, you are going to start out with a value when it's squared is going to be a large expanded value, so you're always going to be subtracting when you're solving for one of the other two legs. So it's always going to be this value squared minus whichever other value is given, and then square rooting to get the actual linear value. So the only decision you have to make is, are you solving for a hypotenuse, or are you given the hypotenuse? If you're solving for the hypotenuse, you're going to do an addition operation. If you're starting with a given hypotenuse, like we are in these two cases, then it's always going to be a subtraction operation. And I hope that's an adequate explanation, and we'll see you in the classroom. Thanks for watching.